Let's talk about the law of sines. So the law of sines is really just a series of equivalent ratios. And we've moved on to general triangles, not just right triangles. So if alpha and beta and gamma are angles opposite sides A, B, and C, then we have this relation. A over sine of alpha is the same as B over the sine of beta is the same as C over the sine of gamma. And you can flip all these over because if we flip all the fractions over, they'll still be equal. So let's use this to solve a non-right triangle. So things we can't use anymore are like the Pythagorean theorem. But the next thing we're looking at is law of cosines, which is sort of a general Pythagorean theorem for all triangles. But let's solve this. So the things that are missing, so when I say solve a triangle, I mean find all the missing angle measures, find all the missing side measures. And so let's find these. So the first thing we can find is the missing angle measure, because still, we're dealing with a triangle, so the angles still have to add up to 180 degrees. And so if I have 50 degrees plus 30 degrees plus my missing one is beta, that has to give me 180. And so adding these together and then subtracting to solve for beta, we see that beta is 100 degrees. All right, so let's fill that in. Okay, so now we have enough information along with the law of sines to find the length of the rest of these sides because we know one of the sides, A. So all of our equations are going to involve, well, at least the first one has to involve A. And we know that alpha is 50. So it tells us that 10 over the sine of 50 degrees is equal to, let's find B first, B over the sine, and we know that measure of angle beta is 100 degrees. So we should be able to find B. So let's solve for B. And so we're going to do that by multiplying both sides by sine of 100 degrees. Okay, and it cancels on the right side, and all we're left with is B is equal to sine of 100 degrees times 10 over sine of 50 degrees. All right. And so we're going to have to approximate this. This is the actual number, but it's not a very useful number. So we're going to multiply this out. And if you multiply this out, make sure you're in degrees. You should end up with something like 12.86. And I'm always going to round to 2 decimal places in this case. Okay, so 12.86 is going to be our answer for B. It's an approximate answer, so maybe we should change that. Okay, and then the last thing we're missing is the side C. And remember, we can't use Pythagorean theorem, so I can't do a squared plus b squared plus c squared, because clearly this is not a right triangle. None of these are 90 degrees. But I could do this again, so let's set up another law of sines equation. So I'm just going to use 10 and sine of 50 degrees again. But notice I could use, now that I know B, I could use 12.86 over 100 degrees as my fully known ratio. But I'm going to put C over its corresponding angle, which is 30 degrees, sine of 30 degrees. And then do the exact same thing. So I'm going to multiply both sides by sine of 30. It'll cancel on the right side. And on the left-hand side, I'll get this. And that tells me that C is approximately, if I put this in a calculator, 6.53. Oh, not great. And that is the last missing side here. So going up here, this is approximately 6.53.